So, differentiating f of x equals x cubed from first principles. What that means is first we just need to get our two coordinates. So x and x cubed, because we're asking to cube x. And then we need to increase x by a little bit, so we've got a change in x, call that plus h. So then when I cube it, it will be x plus h all cubed. So then we know that when we are finding the gradient, which is what differentiation is all about, it will be the limit as h tends to 0. So we're just making the difference between these 2 points really, really small, so that it's that 1 point on the graph of the change in x over the change in y over the change in x. So the change in y will be that, my two y coordinates, and the change in x will be x plus h minus the original x. So as we work through this then, our next line down will be the limit again, as h tends to 0, don't lose that, of, I'm going to expand my brackets here. So to expand x plus h really quickly, one of the things we do at A level is when we're doing working out, draw a line and put your scrap workings at the side. So I know that if I expanded x squared, I would get x plus h squared, I get x squared plus 2xh plus h squared. So I'm just very quickly working it out here. Times that through by x, I will get x cubed plus 2x squared h plus xh squared. Times that through by h, I will get hx squared plus 2xh squared plus h cubed. Just checking I've h'd that, I've h'd that, I've h'd that. So then when I now go and collect my like terms, I've got x cubed. So I've done that. I'm looking for x squared, so there's one there and there's one there. So that'll be plus 3x squared h. Then the rest of it is fine, so plus 2xh squared. Sorry, 3 of them, there's a third one there. Plus 3xh squared plus h cubed. All over, and then let's just simplify this. X plus h minus x is h. Again, f prime of x is the limit as h tends to 0. I'm just going to divide, well, I'm going to simplify through there. Oh, I've missed my minus x cubed. Simplify through there. The x cubed and the minus x cubed will cancel out. Divide through by h will give me 3x squared, because that will cancel. The h there, so I'll get 3xh, because that's x squared, so I only lose one of them. And then h cubed becomes h squared. But we're looking for the limit as h tends to 0. So when I deal with that part of it, you'll notice as we're doing this that I basically do it like brackets. So I deal with what's inside here, simplify it as much as I can before I deal with the limit as h tends to 0, because otherwise I'm dividing by 0 here. So I just deal with the limit last. So as h tends to 0, well, this hasn't got an h in it, so that's not going to be affected. 3xh, as h tends to 0, well, something times 0 is 0, so that's going to disappear. H squared, well, that's 0 squared, so that's also gone. So I'm left with 3x squared.